Hi friends, you're very welcome to the math class. This is Senior 5 Mathematics Paper 1, and we shall be looking at a new topic which we had not covered before, and that is complex numbers. When we talk of complex numbers, here we are talking of a number which can be written in the form, or in short, a complex number is a number which is in the form of a plus b I, where A and B, these ones are real numbers. Like the way you can think of any real number, say 1, 2, or -1, it can even be 0 point something, provided it's a real number. And I has a property, this is a symbol that has a property or a symbol with a property that I squared is the square root, I squared is -1. In short, I is the same as the square root of -1. So that if we take I being the square root of -1 and we square both sides, we end up with I squared being equal to -1. We can use this identity here, or this property, to derive or to show that when you have I squared is -1, so if you ask you to simplify I power 3, this will be taken to be, or you have to apply the identity or the property that we have just looked at, because I power 3 is the same as I times I, but we know that I squared, or I times I, is I squared, and times I, this one I squared alone is -1 times I. Therefore, it gives us that I cubed is -I. We can further use the same idea to show that I power 4 is 1. And furthermore, we can deal with the same property and show that I power 6 is -1. You can still use the same to show that I power 5, this one is going to be -I. This one is going to be I. So you can prove these ones basing on the indices. That's to do with I power 4 being I multiply I 4 times, and wherever you have I squared, you put the property which says I squared being -1. So whenever you have a number to do with complex numbers, it has to be written in this form here. It has to be with a real number and then the imaginary part. If we are to look at the parts of a complex number, say if they give us a complex number z, which is the same as a plus I bar, or a plus bi, then this number here has two parts. It has this part here, and it also has the whole of this other part here. And this first part here, we call it the real part. The real part of a complex number, written as the real of a complex number z. The real part is that part that is not having the I. So the real part of this number is going to be a. And also, if we are to look further to the other part, we call it the imaginary part. Imaginary part, which can be abbreviated as im of a number z. And here the imaginary part, we pick the real number that is having the I. We don't pick together with the I. We only pick this real number here that is having I. Some people might be wondering, how does a complex number look like in terms of considering these two unknowns to be real? We can look at an example. So the examples that we can look at here, the examples, you can think of a complex number. We always denote complex numbers with Z or W. These are the standard complex numbers as established by the URIA. Swiss International came up with these numbers. So we can have a complex number which is say 2 plus 3i, where 2 and 3 are real numbers, and with this one, the real part of the complex number Z is 2, and the imaginary part of the complex number Z that we are looking at is 3. You can think of another number. We can have a complex number W which is negative a half plus 5 over 7i. Here the real part of the complex number W is negative a half, and the imaginary is 5 over 7. You can have more. This can also take on the negative, but provided there is a real part and the imaginary part, then that qualifies to be a complex number. You can have another one, a complex number, say R, which is 3i. This is a complex number which can be written as 0 plus 3i. And here, the real part of the number R is 0, and the imaginary of the number R is 3. So, in the next lesson, we shall look at some more terms that are to do with how we are to apply or how we are to move with the complex numbers. That's to do with the complex conjugates and the operations on the complex numbers. Thank you very much.